Hi guys, it's Elisha from Wava, and I'm here to teach you a little bit about heat and how it affects different substances. So to start off, we'll just be talking about water. And you may be wondering what this graph I have here is all about. And this is basically just a chart of how the temperature of water increases as you add more heat energy. However, you may be wondering why this isn't just a straight line. After all, the more heat energy you add, the more temperature, right? Well, that's actually wrong. We actually have these flat areas for a reason, and it's because of something we call latent heat. So basically, during a phase change, which is when water changes from a solid to a liquid or liquid to gas, you have all of this energy that used to be going towards affecting the temperature, which is now diverted into doing the phase change, so breaking the molecules apart. So that takes so much energy that the temperature actually doesn't increase while it's going through a phase change. And this is useful for a variety of things. For example, with our food, we're glad that there's this plateau before the water evaporates, right? So what would happen is it would just hit 100 degrees and instantly vaporize if it wasn't for this latent heat. So it's a good thing for that. Another useful application is in a coolant system of a car. The coolant can take a ton of heat without actually increasing in temperature. So that's kind of a useful application. It just sits there in that plateau. So we actually have names for these plateaus in this graph, and the first one's called heat of fusion, which is basically the heat it takes to convert a solid to a liquid. The next one's called heat of vaporization, which is the heat it takes to boil the substance. And you may be noticing that it's a lot bigger on this graph than the heat of fusion. And this is all because of hydrogen bonds. Hydrogen bonds are the forces that glue water molecules together. And so water molecules like to be next to other water molecules. But to boil water, you're basically ripping those water molecules apart and throwing them out in the atmosphere. So in order to do that, you have to break all of those hydrogen bonds, which takes an enormous amount of energy. So all of this is related to the specific heat of water and how it changes depending on its state. So you can see that the specific heat is just the energy it takes to heat 1 gram of it by 1 degree Celsius. So it's actually not that difficult. And the specific heat actually changes as the substance is in different states. So you can actually see the different specific heat values of water I have right here. And so liquid water's specific heat is a lot higher than solid or the gaseous state of water. So it actually just means that it takes a lot more energy to heat up liquid water than it does to heat up ice or water vapor. So you can see in just a couple minutes we're going to learn a lot of cool science facts. If you stay tuned, we'll have a lot more great videos. See you next time.